All right, today we're going to look at 7.3 multivariable linear systems. So whenever we have systems with more than two variables, we have some additional elimination methods that we can use to help us solve. So this first one is called row echelon and back substitution. So we have a system here in three variables. We can see it has an X, a Y, and a Z. And we have transformed it to a system, an equivalent system. So the system has the same solution set. It's just written in a different form. And it's written in what we call row echelon form. Row echelon form, you'll notice, has these stair steps, and each leading coefficient is equal to 1. Let's make a little note here. That row echelon form uses a stair step pattern with the leading coefficients equal to 1. So it kind of looks like this, 1, 1, 1. So that's row echelon form. And this form makes it really easy to solve using what we call back substitution. So we start with the solution, we plug it in, we get the next solution, we plug it in and get the final solution. So if we were to look at that real quick, so we'll say solve using back substitution. I'm going to go ahead and I'll copy the system again. And we can use our backfill. So we'll substitute in here and we get y plus 4 times 2 equals 7. So y will equal -1. And then we'll also plug in z and y to the top equation. So we have x minus 2 times y, which is -1, plus 3 times z, which is 2, equals 9. And if we go ahead and solve, we get x plus 8 equals 9. So x equals 1. So for us to write our solution, if you remember, for our solution, we use an ordered triple. So instead of an ordered pair that has 2, we use an ordered triple. And we would put that in alphabetical order. So X, Y, Z. And remember to check. So just put a little note here. Check by substituting. X equals 1, Y equals -1, and Z equals 2. We substitute that back into all 3 equations. So remember, for it to be a solution to the system, it has to be true for each equation. Now, it does not matter if you would substitute it back into a row echelon form or to the original system, where they are equivalent because they have the same solution set. So you might be wondering, well, how do we get it into row echelon form? So we use this strategy called Gaussian elimination. And this is something that you learned last year in Algebra 2. And it's just a series of substitution and elimination to rewrite our system into row echelon form. I think the only difference with last year is we didn't necessarily write our our system in row echelon form. So Gaussian elimination, we just are using our system to create equivalent systems by multiplying, adding our rows, multiplying by constants, adding our equations together to produce new and equivalent equations. So if we go ahead and take the system that we had before, go ahead and grab it, copy it again. Whoops, I don't want that one. I want the one up here. And we'll drag it on down and we'll see how we can write this in row echelon form so that it makes it really easy to solve. So the first thing that's helpful to do is to label our equations. So I could call this equation 1, equation 2, and equation 3. And we're going to start adding our equations together. Remember, we can multiply by a constant, but our goal is to combine equations to make a new equation. So I'm going to go ahead and move these over here so I have some space. Okay, so the first thing I notice is that I can add equation 1 and equation 2 together. So I'm going to add equation 1 plus equation 2, and I'm going to replace it with equation 2. Or I'm going to use that to replace equation 2, to replace equation 2. Okay. There we go. So if I go ahead and add them together, I'm going to use that sum to rewrite equation 2. So I'm going to go ahead and copy equation 1 down. And if I were to add these two together, my x's would eliminate. So I'll write this new equation in pink. So that's going to be 0. And then I'm going to add my y's together. So -2 plus 3 is going to be a positive 1y. And then I'll add my z's together. So I have 3z plus 1 more z is 4z. And then I'm going to add my 9 and -2, which will be equal to positive 7. So that's my new equation 2. And then I'll go ahead and copy down equation 3 again. So now if I label these, I'm going to say this is equation 1. I'll call this equation 4 since it's a new equation, and equation 3. So far, it looks like I'm on my way to row echelon form because I have a leading coefficient of 1. I eliminated my x variable, and this is also a leading coefficient of 1. So now I have some work to do with this last equation down here. So what I notice is that if I'm looking at equation 1 and equation 3, that I can eliminate my x's if I just multiply this equation by 2. So in my next step, I'm going to take multiply -2 times my first equation, and then I'm going to add that to my third equation to replace my third equation. So if we go ahead and look at what that's going to look like, I'm going to multiply this by -2, so I get -2x plus 4y minus 6z, excuse me, z equals -18. And then I'm going to add it to equation 3. So I'm going to show my work on this one. I know I didn't do that on my first step, I'm sorry. So I'm adding these two together, and I notice that will eliminate. I'm left with -y, -z, and -18. No, I should subtract properly, -1. There we go, that looks better. So my new system, let's go ahead and write it over here. So I have equation 1 is the same. Let me go right over here, new system. So far I have this first equation is the same. I have my new equation 4, and now I have my new equation 5. So I'll go ahead and label these. This is the original. This is what we called equation 4, and this is my equation 5. All right, so I'm almost there, right? So now I just need to eliminate this y, and then I want my z to have a positive leading coefficient. So let's go ahead and So what I can do is combine equations 4 and 5, because I know if I add these together, it's going to eliminate my y, and then I'll have a 3z, and then I'll have 6. So what I'm going to do next is I'm going to add equation 4 and equation 5 to replace equation 5. So what will that look like? I'll just go ahead and write my new equation. So these two will be the same. I'll duplicate those. Oops, got an extra y in there. So those will stay the same. And then remember, I'm adding these two together to make my new equation. We'll go ahead and call that equation 6. So my y's will cancel out. I'm left with 3z equals 6. And so you can see I'm almost there. I'm almost in row echelon form. All I need to do is divide this by 3. And then I'll have my stair step leading coefficients equal to 1. So if I divide that by 3, so we'll say I'm multiplying, let's see, equation 6 times 1/3 to replace equation 6. So my final system, go ahead and duplicate that. Oh, I keep grabbing that y, excuse me. Okay, and now I will have my equation 1, my equation 4, and this is going to be my new equation 7. And that will now be z is equal to 2. Remember, I multiply both of these by 1/3, which is the same thing as dividing by 3. So you can see once we get into our row echelon form, using our back substitution like we did in our previous example makes solving this a lot easier.